All right, students, Ms. Slyman here, and now we're going to talk about binomial distributions. So we've seen a few examples of binomial probabilities already, but we're going to formalize it now. So we're going to look at the binomial distribution, the mean and variance, and knowing that we don't have to prove either of those things. So a binomial experiment, a series of independent trials, so some sort of experiment that we repeat n times, only two possible results: success with probability p, failure, which we call probability q, but of course q is just 1 minus p because those are the only two outcomes. The way we calculate individual probabilities is by using n choose r. You might remember this as the binomial coefficient, which is why we call this a binomial distribution, times p to the r, q to the n minus r. So all of this should look very similar to x plus y to the n. So my expansion of that is going to be n choose 0, x to the n, y to the 0, plus n choose 1, x to the 1, y to the n minus 1, etc. So when I'm thinking about a binomial distribution, the reason that I have my n choose r in front is because that's talking to me about the ways that something can happen. So if I think about flipping a coin 6 times and then letting x be the number of times that I see heads. Well, if I'm thinking about seeing heads 3 times, I don't know which order I see those heads. It could be that I saw heads, 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 and then 3 tails. But I also could have seen heads, heads, tails, heads, and then 2 tails, heads, heads, tails, tails, heads, etc., etc. So the number of ways that that happens would be 6 choose 3. The probability of getting heads is 1/2. So that would happen 3 times. And then I would also have tails happen 3 times. So that's why we have this formula with n choose r, p to the r, q to the n minus r. But of course I can use my calculator as well. If I'm looking for exact values, I can use Binom PDF. It will do all these calculations for me. And so for this one, with my table of values here, what I could do is I could come into my calculator, and in my y equals, I'm going to clear this out. So I could type out my formula fully, but I can also just go into my distributions and pick the binomial PDF. So P there standing for particular value. So I've got 6 trials. Probability of success is 1/2. And my x value I'm going to let be x. So let's paste that into our y equals. And now I'm going to go into my table of values and see that for values greater than 6, my probability, of course, is 0. But for x equals 0, I get my value. If I click over to the right, I see my exact value, so 0.015625. And then I could fill in all of my values. If I want to draw my probability distribution, then I want to look at a bar graph. So I would need this data in a list. So I'm going to come into my stat and I'm going to make a list. So I want the values from 0 to 6. And then in list 2, well, I'm going to go back to my binom. So first I'm going to clear this out. And I'm going to go back to my Binom PDF. And now I'll say that my trials is 6, my p-value is 1/2, and now my x value, I'm going to make list 1. So I've got all my values again. I see that same value, but now I stop at 6 rather than seeing all those zeros. This also lets me go into my calculator, go into my stat plot, and make a bar plot. So list 1 is my x value, list 2 is my frequency. I'm going to turn this on. I'm going to go to my zoom and say that I want to zoom stat. And this did not work so well, so let's go back into my y equals and clear this out. And now let's see what happens again if I zoom stat. Nope, still just one big bar graph. So let's go into my window settings. 0 to 12, well, let's make that 6. Let's count by ones. Okay, we could say that. Sure. And now I see a much better distribution for my values. That first one was very small. My values got bigger until my most likely one at 3. Having my data in list 1 and list 2 lets me go in and calculate my mean and standard deviation. So I've got that in there. I can do my 1 var stats. And I see that my mean is 3. And my standard deviation, 1.22. Let's go ahead and look at the exact value. Well, we'll see if there is an exact value. Actually, there probably isn't going to be since I had my probabilities there, but let's try it and see what happens. Oh, we do get an exact value of 3/2. So my standard deviation is going to be square root of 3/2 since my variance was 3/2. And notice with these values, this 3 is the same as my 6 times 1/2. My variance is going to be the square root of 6 times 1/2 times 1/2. So this would be 6/4, which of course is 3/2. And this is not something that I would expect you to necessarily see. It's because I know that in a binomial distribution, I didn't write it down here, but in a binomial distribution, my formula book tells me as well, my mean is NP, my variance is NPQ.